Hi, in this lesson, we're going to look at heat energy and specific heat capacity. Now, if you remember, heat energy is represented by the letter Q. It's not a capital H because that represents something else called enthalpy. So chemists have decided to use the letter Q to represent heat energy. So heat energy is measured in a unit called joules. And joules is represented by a capital J. Okay, so joules is a unit. Heat energy is a variable. If you have a value of Q that is positive, that means something is absorbing heat. Okay, heat in terms of energy. Now, you guys have been taught a particular term called endothermic. So essentially, positive Q just means that something is endothermic. It's absorbing heat energy. Negative Q, on the other hand, means releasing heat. And the term for this was exothermic. So something absorbing heat might change phase from, let's say, solid to liquid. Okay, while the opposite, if it's turning from liquid to solid, might actually be releasing heat. So if we look at an example, let's say we had a cup. And within this cup, we have some water. Okay. Let's say that we have exactly 1 gram of water, which is H2O, at 1 degree Celsius. If we were to add a little bit of heat to that 1 gram of water, okay, and we try to raise the temperature, okay, so we're going to add heat to raise the temperature to 2 degrees Celsius, how much heat energy would we have had to add? Okay, well, the amount of heat, it turns out, so the amount of heat needed to do this, okay, the amount of heat that we need to raise the temperature of 1 gram of water by 1 degree Celsius is exactly 4.18 joules. Okay. It doesn't seem like much, but we're only going up by 1 degree Celsius. So this particular example here, it's very, very specific to water. Okay? And it's a very specific amount of heat energy. So specific that we call this the specific heat capacity. of water. Okay. So this is represented by capital C, lowercase p. That means specific heat capacity. And for water, it's equal to 4.18 joules for every gram degree Celsius. So this means it takes 4.18 joules of energy to raise the temperature of 1 gram of water by 1 degree Celsius. That's what specific heat means. So if we had a block of ice, and it too is 1 gram, okay, the specific heat that's required to raise the temperature of 1 gram of ice by 1 degree Celsius is 2.06 joules per gram degree Celsius. And if you had, steam, okay, so now our H2O molecules have vaporized into a gas, okay. If we had 1 gram of steam, the Cp of steam would be 2.02 joules per gram degree Celsius. So this is very, very specific, okay, to the substance and the state. So when we look at all three numbers together, we can determine that water holds the greatest amount of heat energy out of the three states. Okay. So because water can hold the greatest amount, okay, this is why it's called capacity. Capacity means how much it can hold, what is the limit, almost. Okay, so capacity equals storage. This is actually very unique to each substance. So in the next video, we'll look at exactly how to calculate heat energy. Okay, and we're going to use a formula that looks like this. So Q is your heat energy. That is going to be based on mass, M, in grams, times the change in temperature, T2 minus T1, times the specific heat of a substance. Okay? So if we want to find out how much heat energy a specific substance requires in order to change from one temperature to another, this is the formula that we're going to use.